This lesson is about extrema on an interval. Another way to say this would be we're looking for how to find the maximums and minimums on an interval. So extrema, just so you know, is just a word that covers both maximums and minimums. So if they ask for extrema, they're looking for both the maximums and the minimums. We're going to look at a theorem called the extreme value theorem. It says if f is continuous on a closed interval, a to b, then f has both a minimum and a maximum on the interval. Now it may sound super obvious to you that something would have a maximum and a minimum. It's got to have a biggest and a smallest, right? Well, that's almost true, but it's actually really important, that very first line, if f is continuous. For example, if I have a picture like this, that does not have a minimum. There's a hole where the minimum would be, and there's no way to determine a minimum because of that hole. And that is because you're not continuous. Now, you may have something that's not continuous that still does have a max and a min. This second line I drew, it still has a minimum and a maximum, even though it's not continuous. So, not being continuous doesn't mean you won't have a max and a min, it's just not guaranteed. But according to the extreme value theorem, if you are continuous on a closed interval, then you are guaranteed a maximum and a minimum. So let's look at these pictures for a second. I'm going to mark where all the minimums and maximums are. We have a max here, we have a minimum here, we have a max here, and a minimum here, a max here, and a minimum here. Now what I would encourage you to do here is pause the video for a second, and I want you to see if you can figure out what the pattern is on where maximums and minimums tend to pop up. There's a pattern to the kinds of places max and minimums occur. And I'll give you a hint. There's two different types of places maximums and minimums occur. So if you want to try to figure it out on your own, go ahead and pause right now, and then I'll tell in just a second. Well, if you look, max and mins happen one of two places. They either happen on endpoints, which I'll mark in red, or they can happen where the derivative or the slope is equal to 0. So if you look, I marked in green the three places where it happened that it was where the derivative equals 0. So max and mins happen in one of two places. They either happen at endpoints or what we're going to call critical points. And critical points are any points where the derivative equals 0 or does not exist. So for examples of where it equals 0, you can just look at the previous slide. Back up a little bit, look at those pictures again if you need to. For the does not exist, a really easy example is like y equals absolute value of x. That has a minimum right there, but the derivative wouldn't exist because of the corner. So it may be that the derivative doesn't exist. The original function is still continuous. Absolute value of x is continuous, but the derivative doesn't exist there. So when we're looking for maximums and minimums on an interval, we just have to look at two different places. First, at endpoints, and second, at critical points. And again, critical points are places where the derivative equals 0 or does not exist. So for our first example, we're told to find the max and min for x cubed minus 3x squared on the interval -1 to +4. I already know my endpoints. They're -1 and 4, but I need to find my critical points. To do that, I need to take the derivative and set it equal to 0. Okay, you should always double check. Is there anything that would make this derivative not exist? No, not in this case. Mainly there you just want to look out for denominators, and here we don't even have one. But we do need to find out where it equals 0, so let's factor. We can pull out a 3x, and we get 3x and x minus 2. So from this piece you can get that x equals 0. From this piece you get x equals 2. So we found two critical points, and there may be 0, there may be 1, there may be 2, there may be 15 of them. You can have any number of critical points. One thing you do have to check though is make sure that they fall in your interval. So double check, does 0 and 2 both fall within -1 to 4? Yes, so we're good. So now that we found the critical points and we were given the endpoints, our next step is to plug all 4 of them in this case, it could be a different number in a different problem, back into the original equation. And it must be the original equation. So I'm plugging my endpoints, -1 and 4, and my critical numbers, 0 and 2, back into the original problem. So I plug -1 in, and I should get -4. Plug in 0, and I get 0. Plug in 2, and I get -4. Plug in 4, and I get 16. So to figure out the max and the min, we have to simply look at our results, our y values. To find the maximum, just look, where's the highest y value? Well, that's right here at 16. So here's our maximum. And for our minimum, we just look for the smallest y value. Well, if you notice, we have 2 of the same. And that's okay. You're allowed to have more than one min or more than one max if they are identical. So we actually have 2 spots where it reaches its minimum, and that's at -4, 2 -4, and -1 -4. Alright, so let's look at the process to solve these problems. There's basically 3 steps. First, you find the critical numbers. Second, you plug the critical numbers and the endpoints, that should be plural, into the original function, okay, into f of x. Then the smallest y value or y values is the min, and the largest y value is the max. Now I want to talk about this part down here for a moment. If they ask you where the max or the min occur, then they're asking you to give them the x values, because that's where they occur. If they ask you what the max and the min actually are, that's when you need to give them the y values. So if you think about it, max and min has all to do with how high and how low you are. And that's a y value. Y value is the up and down. So y values are what the max and the min actually are, whereas x are where they occur. Looking back at our first example, the max here equaled 16, and the minimum here equaled -4. But the maximum happened at x equals 4, and the minimum happened at x equals -1 and 2. So y is what the max and min are. X's are where the max and min occur. If you're unclear about that, you can give the whole ordered pair, and that should be sufficient pretty much for anything. So let's look at 2 more examples. First, find the extrema for f of x equals 2x minus 3x to the 2/3 on the interval -1 to 3. My first step is to find the critical points. So I take the derivative, and then I want to figure out where this derivative equals 0 and or doesn't exist. So if I set this equal to 0, one thing I would always recommend with this is don't leave exponents negative. Go ahead and move them down to the bottom. That's going to make it easier to solve for 0. It's also going to make it easier for you to see that, hey, there's a denominator. And I can't have x in this because x would make the denominator 0. Sorry, I can't have x as 0 because that would make the denominator 0. So I can go ahead and write down that 0 is a critical number, a critical point, because if I plug in 0 right there, I'm going to have a problem and my derivative won't exist. So now I'm going to add this whole piece over to this side. So I get 2 equals 2 over x to the 1/3. Then I multiply both sides by x to the 1/3. And I get 2x to the 1/3 equals 2. Then divide both sides by 2. And I get x to the 1/3 equals 1. Then to get rid of the 1/3, we cube it. So x equals 1. So our critical numbers are 0 and 1. Now remember, we have to make sure that that falls in our interval. Now our interval is from -1 to +3, so 0 and 1 do fall in that interval. It may happen that you'll get some outside the interval, and if that happens, you just throw those out and don't worry about them. So now we need to plug in f of -1, f of 0, f of 1, and f of 3. Because we're plugging in our critical points and our endpoints back in the original. If you're allowed to use your calculator, I want to show you one quick way to do this. just plug your original function in for y equals. Oh, lost my x there. Hold on just a second. There we go. Sorry, I had some trouble with that. Okay, so 2x minus 3x to the 2/3. Plug in the original equation. I want to stress that, original. And then just go to your table and plug in these points. -1, 0, 1, and 3. And so it does all the work for you. -5, 0, -1, and then -0.2403, I believe is what it said. Yes, just forgot the negative, but that's it. Alright. So there we go. Now we just have to look for our biggest. Well, it turns out 0 is the biggest here, so our maximum is at 0, 0. Or you could say our maximum is 0. And our minimum is -5. Okay, last example. Find the extrema of f of x equals 2 sine x minus cosine of 2x on the interval 0 to 2 pi. Alright, so we need to find the max and the min of this equation on the interval 0 to 2 pi. So we first need to find out where this equation, its derivative, equals 0 or doesn't exist. So let's take the derivative of 2 sine x, which would be 2 cosine x. And the derivative of cosine of 2x would be positive sine of 2x times 2. Okay, the derivative of cosine is negative sine, so that makes it go back to a positive since there's a negative in front already. And I had to use the chain rule because of that 2x inside. Now I want to set this equal to 0. Okay? With this one, I would recommend we use the calculator to see if there's anywhere it equals 0 or does not exist. So I'm going to plug the equation in my calculator. I shouldn't have any problem with it not existing. Cosine and sine are continuous, so that shouldn't be any issue. But we can see if there's anywhere on the interval that it equals 0. If you use Zoom Trig number 7, then it automatically puts your window from -2 pi to pi, or -2 pi to positive 2 pi. Okay, so you can see here that we actually have several spots where we're going to equal 0. So I can do second calc, number 2 is 0. And remember, I only care about it from 0 to 2 pi, so I'm only looking at it from here to here. So I count 1, 2, 3, 4 spots. So I tell it left bound, hit enter, move to the right of that spot, hit enter, and then don't worry about the guess, it figures it out. So that's actually pi over 2, if you recognize that decimal, 1.571. So that's pi over 2 as one of our x values. Then you go second calc again. 2 is 0. Now we want to find the next one. So we hit enter for left bound, enter for right bound, enter for guess, and we get 3.665. Let's see, I believe that's equivalent to 7 pi over 6. Okay, I'm going to pause right here and I'll get the other two and then we'll move on from there. Okay, so I went ahead and found the other two zeros, and so we had a total of 4 critical numbers here. There were 4 places where this derivative equaled 0. So now what I need to do is plug those 4 critical numbers and the 2 endpoints into my original function. So I went ahead and plugged into my original function into y equals. Make sure you're doing this into the original. And then I went to my table and I plugged in all 6 values, the 2 endpoints and the 4 critical numbers. So if you look, I have 2 minimums. both 3.665, which is the 7 pi over 6, and 5.759, which is the 11 pi over 6, are at negative 1.5. So my minimum is negative 1.5, and it happens here and here. Now my maximum, my biggest one is 3, and that happens at 1.57 or pi over 2. If you just do all these with decimals, the 3 places, you should be fine. It's still going to give you the biggest and smallest correctly. So the maximum is 3, and it happens there. So 3 steps to finding extrema on an interval. Find your critical numbers, plug your critical numbers and your endpoints back into the original equation. Your biggest y value is your max, and your smallest is your min.